holding on if you stayed through the break. So, um, just time to add new tests, I guess. So we can now test this initialization speed, which is pretty nifty. But we need to set up other tests. So let's try another one. Let's see if I can use the same pattern again. So the new one would be something like, and you know that, first of all, this template here, this template function, if we're going to keep that, would go like right there. So this is like line measure test, or start measure test. Yeah, okay. So start measure test is the test of how quickly can it find the beginning of each line, because that's one of the things it has to do. And it could be that it costs more depending on how quickly things stream, or not, and we'll find out. So that would be under abstract, I believe. Measure starts. Don't care about remeasure starts. Alright, here it is, measure starts. Yes, so what I should do is take a look at how this works in file view, because I believe this has a little bit of complexity the way I actually do it in there that I'd like to mimic in here. Yeah, so we will need another one of these. This will be start, or not start measure, this should be measure starts will be a better name for this. And then what will happen is I'll name this measure starts. Whoops, on each one of these. And I don't think I need any buffer measure starts is not type dependent, so I don't need any of these type parameters in this case. Of course, init time's not the right time. This is like measured time now. Alright, and now we gotta make the function. So, void measure starts is gonna be a template. Which takes in a buffer type. This does not need any of these, actually. So there we go, we just pass in a buffer, and then what we have to do is we'll say the line start starts gets initialized like so. And then after that, we begin a buffer measure start state. And there's a loop here that goes on this condition. Measure start, here's the state, here's the buffer. For each one, we'll take line max. Count is the state count. Count plus 1. Max equals target times 2. New lines equals int pointer. Alright, so that's interesting. I have a realloc working there. Does the standard library provide realloc? Yeah, I don't really want to do that because I don't know if it's going to behave the same way as my realloc. I'll just worst case it and say that the realloc always does an alloc and move, so that I don't end up getting like a random stuff happening that sometimes favors one and not the other for random reasons, you know. I'll just worst case that. Okay, so here's the how much I need. Don't need a separate line for that. Then I can mem copy into the new lines out of the line start. The count. And then update, I can free the old line starts and update to the new lines and to the line max. Alright, and then when it's all done, line count equals state count. That's a kind of a nasty API there. If I were to make this into a nice API, I would want to fix that. Namely, the line count thing at the bottom. It's kind of lame. Okay. So, now, that's hopefully gonna work. Yes, 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 yes. T end minus T start. Okay, afterwards, we don't need to free all this crap. All we have to do is free line starts of each one, because they all work the same way right now. Now, this is sort of before I've gone in and optimized for different cases. So it might be that one guy wants to optimize differently than another to get that metadata figured out, and they don't want to actually store it in just flat arrays. And so we can't necessarily just take whatever happens now as law, but we will find out. We'll find out if it's you know, relatively good or not, and if they differ a bunch or not on this particular setup right now. Measured starts test. So here are the buffers. Starts test. Does it actually need the file that it takes in? No, it doesn't. No need for that file. We'll do 100 repetitions like before. Here's the scratch size, and we don't need to save this for any other purpose, so no output. What would be wise now is to start turning off tests that aren't being run, since they take time. So I'm going to take care of something while this runs. Uh-oh. That's bad news. So let me close this down. First of all, I need a new line after my samples. Second of all, if I take out the initialization test and rebuild this and run it over here, do we get some clue as to what's going on sooner? Well, yeah, the clue we get is that that doesn't work. Okay, so I'll run the initialization test, but I'll run it with one repetition, so it just gets done right away, and we go on to the next one. Buffer beginning it. I don't want that anymore. So who is causing the trouble? So the very first one, if you look at the buffer, the line starts. Interesting. Measure starts. I think I needed to set the buffer max at some point for one thing. But why is the data messed up? We're starting at 0, going to size. It's just a golden array. The absolute position is 0, the size is gigantic, so there's your end point. Y is 0, the absolute position is 0, so the data... Yeah, what happened there? That's kind of weird. It goes into stringify this. Buffers, valid... no... It's not. So I must have been freeing the data anyway. Oh, this says if I plus 1 does not equal 100. I want that to say if I plus 1 does not equal test repetitions, right? So if I ask for 1 repetition, I comes through as 0, and that says, oh, that does equal repetition, so don't do the free on this round. That way the last round doesn't do the free, is the hope there. Is the data valid now? The data is still not valid. I'm missing something here. Something doesn't make sense. Something does not add up. So the first time it comes through, it performs a malloc on that page. So I'm going to keep a look at that. What is the value of that? OXE 10040. We'll treat that as a character pointer. Alright, it goes on, we end in it. Other things happen. This stays valid the whole time. No one's been touching it. I thought... Ooh. Thought we changed that. Did I fail to rebuild after I changed it? What's the deal here? Oh, this is the wrong test. Okay, the data is valid. Goes into measure those. Goes in there, and we have valid data. So it should be able to get through now. Broke somewhere else. Okay, this is where we were initially breaking that caused us to start debugging, that caused us to mess other things up. Okay. Alright, so we're actually at the gap buffer where things go wonky. The line count is ginormous. I wonder why that is. Well, I guess it's already been adding in stuff. But why would it have any line count if it's just starting? You know? I wonder if it's okay through the first time. Yeah, it is. And then it comes out and it's like, okay, great. That's not a problem, and line starts is good, but it comes through a second time and things go weird, right? Yeah. Why is that? I really don't like dealing with other people's allocators. Because now I can't just look and cheat and figure out what went wrong. Yeah, somewhere this many layers deep into this freaking call stack, it must have done like an error check or something and discovered that there is a problem with the heap, but what would that be? Oh, you know what it might be important to do? Is whenever I measure start, since I might repeat this test multiple times, I really ought to be setting these up correctly. So it's like line max equals 0, or equals max, line count equals 0, and I'm not sure why that would matter necessarily. Unless somehow the first buffer having a positive line count caused weirdness. It's hard to say for sure. Doesn't seem terribly likely, honestly, but let's take a look. Oh. Okay, so maybe we're working after all. Maybe that was the bug. It was probably the max thing. I should go look into what it was. I think it was probably because of the fact that max was 0. and not because of this. So let me take that out and look at it again just to confirm that hypothesis. Yeah. So it was the fact that I wasn't setting max was the whole problem, but why would that cause the problem, I wonder? Only one way to find out. I'll put a breakpoint here. Wait, I can't do this yet. I gotta pull that out. So if that's not in, put in the breakpoint. Max is 0. How does this function work? It thinks its max is 0. It does a little bit of work, and then it's, you know, gonna go until the, oh, there we go. It needs more memory. And so it comes out and says, hey, give us more. And so then it adds 1 there. Max becomes 2. We get some new lines, which is fine. We copy nothing into there. We free the old one, which had a bunch of stuff in it, right? So we just decreased from having like something with 1,024 entries to 2 entries, but okay. And now it's got a line max of 2 and it does some work. And it actually stores stuff. Hello, hello, Eskilson. How's it going? I'm working on an experiment to measure the effectiveness of various text buffers. I'm working on it for my ongoing project 4coder, and right now I'm trying to debug some issues with my testing system that appear to still be there. Been working on the testing system just for today, so it's reasonable that there's still bugs in there. If you want to take a look at some of the code I'm working on, it's all public domain right now. And the stuff I'm working on today will be posted at the end of the day on this GitHub repository, so you can check it out there if you want. I posted the link in the chat. Yeah. So anyways, that's what I'm working on. And right now there's this bug where, well, I've actually I know how to fix the bug, but I'm not sure why the bug was happening, so I'm trying to investigate. Something is really weird about this loop right now, which is that it doesn't appear to be finding any new lines, but could just be on a long line, I suppose. So I'm gonna pop that up so I can watch it. Okay, there it just found a new line. There it found another, it's too big, so it pulls back out for more. Oh, what if it gets messed up right here? It could definitely be getting messed up right here, I think. I wonder if it hits this at any point. Let me watch that. Ah. I equals size, count, and max. Okay, let's do it a second time. No, so that's not it, but that seems like it would be a bug, because if count equals max happens right here, it would be a problem, so I should fix that for sure. I'm not sure that that's the original bug that I was talking about, but it's lurking in there. Okay, so let me run it again and see if I was right that I was getting tripped at any point, or if there's something else causing that. Go away, go away. No, so that, as I suspected, was not actually causing the bug. So it's still a little bit of a mystery why the bug is happening. Maybe it's happening because during the first step of the golden array, or the second step of the gold, like it's happening on the second time through right at the beginning. Maybe that things go weird. Maybe. So I set the max. Now let me take a look at what the buffer believes in terms of its data right now. The buffer believes it's got this oh, that would be it. Alright, so this is the problem. Because I wasn't resetting the buffer's line max, oh wait, line max is 0. Wait, actually, let me go through a second time. Okay, I still know what it is, I just wasn't at the right spot in the code. Okay, so the actual max is like 1024, and since I wasn't setting it here, it thought its max was this giant number, and so it was overwriting past that point and corrupting the memory. So that's what was going on. That's why setting that max works. Ding. Okay. Super. So now, I bet we can run this test. So the first thing that happened just there was it took one sample to initialize everything. If I'll pull this out of the way for a sec while it runs. You can see I have an initialization test and I'm running it once right now. I can run it 100 times to get better like statistics on it. But then we ran 100 samples on the second test. And I probably need to put like a spacer after those and maybe like print out the name of what type of data is coming out. That might be nice. So 100 samples of measuring line starts, and we can see that in a debug build, the golden array was about neck and neck with the gap buffer and outperformed multi-gap a little bit and outperformed the rope significantly. That appears to be true everywhere, except it looks like the golden array maxed out actually somehow, which is nuts. Again, those maxes seem to be super variable. Let's try compiling with both tests on full. Wait, before I do that, I wanted to go to these tests, initialization test, and say that we print before one line of the name of the test. So I can do like print name, measure starts, initialization. And then at the bottom, printf an extra new line. I'll define print name to go like this. Define print name as printfing a string colon new line, and that string would be function. Right? Then I can just take this and bring it down here and replace the middle line like so. Now I want to build the fast version. Fast test is what I meant. What was that I just saw? That was unusual. I think that was probably a result of not compiling some things out, but compiling other things out because I had the wrong thing. But what is this? yeah, so that's because of well, I ran build, which is like a not even a real script anymore, so I'll just ignore it completely. I need to build all. I should maybe make a new script that's just build the test optimized, because that Win32 for it takes too long. And then I wouldn't have to type in as much stuff. So let me do that real quick. Build all. Build experiment bat. So it's the same basic stuff, only I'm also going to pass in o2/d fast test, and there we go. So now all I have to do is build experiment, and it just runs that, and then I can run experiment. Alright, so we'll wait a little while for it it's now running in optimized mode, so it won't take it as long to do 100 as it did to do 100 in debug, but it will take it a little bit of time to do initialization now, because I've told it to do 100 samples of initialization. Cool. And I wanted that so I could compare how much of my initialized time does something take here versus there, right? So it looks like the golden array is actually kicking butt in the measuring the starts, which was to be expected, and in that. So if you were to add up these things, you'd get like the total initialization time. Looks like the gap buffer and the multi-gap buffer have about the same speed for measuring starts, which is interesting. Because obviously it takes a little more time to first initialize the multi-gap buffer. That just sort of shows a general trend I would expect, as does this. So yeah, it looks like if you were to take a look at just these results here, that suggests the golden array will be able to initialize in 40 microseconds on a 10 megabyte file. That's 40 microseconds, and like the next one up is 50, right? It's almost 50 microseconds. The worst one out of all of them is 60 almost, well, more than 60, 62 milliseconds. Did I say micro? It should be 1,000 micros or a millisecond. Yeah, so anyway, the golden array still looks pretty good, but that's just because we're testing it on what it's strong on right now. So let me do one more thing. We need to do there it is. We need to switch back to this so that we can do a few tests in a row and make sure that the variability looks okay. And obviously you can always improve your variability, and by improve I mean reduce it, by just running more steps. So I do like actually 1,000 or 10,000 samples when I was really getting my data, but I don't want to spend forever waiting for samples when I'm waiting for 10,000 samples when I'm still building the test system up, you know? Okay, so this time we got 17,000 microseconds, or 17 milliseconds. Up here we got 18 milliseconds. There's about a variability of 1 millisecond there. What about this one? 29 versus 26. That's pretty wide. That's 3 milliseconds. Have to be sure I'm comparing measure starts against measure starts and not against the initialization test. That wouldn't be any good. What about minimums? 14, 16, 17, 18. 13, 16, 16, 18. So those are pretty less variable still, so that's still an interesting property. There's like a minimum, they just never break below their minimum. They hit it more often. It suggests a sort of a right skewed bell shape, right? That you have a bunch of things on the small end, so that you always have, like, you never have crazy things that spike to the left, because most of your things tends towards the small end anyway, and then once in a while you spike way out to the right. Which you can decide for yourself whether that's the kind of behavior you want. It does mean that you have a nice lower average if that's the way you skew and not the other way, so that's good. But it also means that in worst case you can have unpredictable spikes. Okay, so we have a measure starts test working. Let's talk about doing the next thing I need to do. So measure starts is good. We also need to measure width. So let me pop up to where my measure starts function lives and make a version of it for measuring width. Okay. So measure width. Let me look at how I do this in the editor. Measure width. So all of this is much cleaner because it knows the number of lines at this point, so it just goes boom. We need a font though, you know? Which I don't necessarily love, but it's how things work, so I have to somehow provide a font to this to work, right? Because, I mean, at the very least I need some width data. And having real width data would be nice. I think maybe for now I can do something really cheesy. If we just set it to be monospace and I pass that in, and then I tell it that there's no stride, it'll always read the 8. So that's kind of fun. But yeah, we'll want to work on actually getting proper fonts in here. The other thing this has to do is I need to make sure I've got enough memory. So how does grow width as needed work? It's basically a matter of look and see if the line count of the buffer is greater than the buffer's width max. And that over there says or if this equals 0, so I'll match that. And then let's see, it says do round up the line count to 1 kilobyte and store that into the new max. New max is less than a kilobyte, then new max equals the kilobyte. Well, for the sake of this test, I know measure widths is supposed to mean that it's not a reallocate situation. So I really think I just need to do an initial allocation for this particular case. Line width equals float star malloc new max times the size of a float, and then the width max equals the new max, right? I have file view open twice. Oh, because my other file view, right, is a fake one because of that situation we had earlier. Okay. Alright, next up we have that little measure width function with a template. Now we can write the function for this measure time, test repetition. Someday this will have to take a font pointer, since that has to do with measuring widths. But for now we just do that. Measure time, test repetitions. All I gotta do is change all these measure starts into measure widths at this point, I believe. Measure starts into measure widths. And I should turn these line starts into line widths. Right. And buffer measure widths. I should set the buffer width count. Why do I have two file views again? How is that even possible? It's just opening the file view as file view 2, which is weird. I wanted to kill that one, kill this one, and then when I open file view, it should be file view 1. End of story. Nothing else to it. It's a little weird. Anyway, let me look at width. No, it's under. It'll be easier to see under like a golden array. The widths. Okay, widths count equals 0. Oh, not ready yet. I have to ding. I have to go down there and hit ding, and then I have to measure widths. Stats out. Stats out. Stats out. Silence test. just setting up a little way to silence the tests if I want. Alright, so it looks kind of like that. Print that. There it is. I just need to plug this middle one in here. Wait, no. Ah. Build the experiment. Run the experiment. Alright, so we were able to run that, no problem. Let me put an actual amount of time on the clock. Uh-oh. Now we have an issue. So I bet you that has to do with the fact that I'm repeating stuff again. Because that's when I always introduce bugs, is when I do the same thing more than once. Yeah, okay. So if it's got to do with repeating the same thing, what would that be? At the very end I do free all of my widths. Oh, but I don't reallocate because of the fact that I mimic those. Yeah, that can really just go. I'm just going to say at the beginning, I always do that actually. And that's that. No second thoughts about it. Okay. Now let's bump that up back to 100. And now I'm just testing to see that the variability is reasonable still. Then it looks, because if it's not, then that can be a sign that there's something wrong with the way I'm testing things. Interesting. Yeah, it looks like the golden array wasn't even the best at that, which is interesting. Unexpected too. I would have expected the golden array to still be the best at this. But it looks like the gap buffer is actually a little better, and somehow the multi-gap buffer is even better than that. Although it could have been an anomalous spike on the gap buffer's part, it looks like. Yes, somehow the widths play better with the gap buffer than with the golden array, it seems like. I mean, that's holding steady that the gap buffer is performing better, which is kind of crazy, I think. It could also be a matter of the file I'm picking, so I want to pick some other files and run them as well. But certainly on this file, it's pretty much holding true that the gap buffer is almost a little better than the golden array. Yeah. Every single time. Alright. So, that's cool. We can maybe run I can stop doing that via the comment thing. So that's pretty much everything that is that it takes to initialize a file, if I remember correctly. And init, after which it does the starts and the widths. And I mean, it sets up the undo redo stuff, but I'm not really testing that directly. and that's just a bunch of allocs, right? So yeah, now what we can do is we can play with, if we want, we could play with these record outputs here and get the sort of sum of who has got the best average overall for startup, right? Because these are the three things it takes to initialize, measure the starts, and the widths. That's what I have to do every time I open a file. And so that means now what we can do is we pass in a struct there, and it will, like, we run all three of them at full time, pass in the struct, and then what comes out will show us some numbers we can add together and figure out which one opens a file the quickest. So let's do that, because it sounds interesting to me. And I need a good test that the record output is working. So time record, we'll have init rec, starts rec, and widths rec, right? And then each one goes in here, init rec, starts rec, and widths rec. And then after all of that, we can make one more time, wait, that should be record stats, right? And then I need one time record for average file open, which is just average file open dot buffer equals init rec dot buffer plus starts rec dot buffer plus widths rec dot buffer. 1, 2, 3, 4. You know, I'm really getting the impression that I should just do an overloaded operator for these, because then I could just do that this equals this plus this plus this. So let's do that, because there's been enough of the times where I've had to write that crap that seems like it'll be worth it. So time record operator plus time record A, time record B, R dot buffer equals A dot buffer plus B dot buffer, gap, 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 multi-gap, 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 rope, 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 return R. Alright, so that can add those two things together. I think there's a few spots where that would be useful. Yeah, so like right here, instead of all this, we could just say that expected equals expected plus the record. Those can stay the way they were, that can stay the way it was. Alright, cool. Bong, bong. And then what I can do is I can printf file open, new line, print record average file open. That's what I should actually call this. Here's the average file open time. Whoop. Oh, it's not called average, it's expected. Seriously? Okay, I thought that was like totally allowed. I'm not sure I understand. Should these be const? Okay. Now we have to wait for 3 tests to run so that it can give us the full prognosis. I don't know, guys. You think that's correct? Does that look right? Because it looks totally wrong to me. What? God damn it. Why does nothing work? Okay, so it's almost certainly some like flaky business with the operators or templates or something nuts. So what I'm gonna do is put this in fast mode and look at what happens when it comes out the other end. Okay, so we have 3 of these. Whoa! That wasn't even triggering before. Guess I should run these in debug mode maybe. Before I run them in release mode so I can have my asserts. So what's going on here? Let's see. I need to look at I and J. $23,495 is where the width thinks that should start. But if I go down to 1025, he thinks 23,507. 23,507, 23,495. $23,507. Who was it that messed up, by the way? It was the rope buffer. So this could definitely be a streaming issue on the rope, which is annoying because why didn't it come up sooner? I mean, this should have been caught. I'm gonna run normal 4coder. I'll open up test data. I want normal test, please. Large. Wow, okay, so ropes are actually totally broken, it turns out. So, yeah, what's the deal there? Alright, so first of all, let me take a look at this buffer, make sure everything looks kind of okay-ish. File buffer. Okay, there's no more free ropes, there's no more free nodes. I gotta tell it to request more memory still. That might improve its initialization time, you know? Anyway, when it runs that, it gets a line count and a line max and all the line starts in the world. The node right here, 9903524, should match this guy, 9903524. It does. There's more nodes in this than I care to browse through. So if there's a problem with the stream, which is what it appears to be, not the Twitch stream, the stream of characters coming out of the rope, the easy way to catch it will be to take a break from working on this timing stuff, and we'll do a correctness check right here. So, correctness, stream, I'll call it stream check test. We'll take in the buffers. And then what it's gonna do is stringify parts at a time, blah 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 blah. Got it. Okay, so test main. I'll keep all of the time related things together. So stream check test takes in the buffer set of buffers, and then what we do is we'll say, alright, so we're going to need an I, a stride, a size. Let size equal the buffer size of buffer's buffer. And then we'll do some asserts, make sure that the size agrees with all of the other buffers. Then begin a loop that sets I to 0, asks that I remain less than size, and increases by the stride. I'm going to rename stride to page size in a second. Let's get some scratch memory in here. Alright, page size will equal 1 kilobyte. And then what I do is I say, alright, we need 2 pages to be pulled out. So there's buffer 1, or page 1 equals car star scratch, and car page 2 equals page 1 plus page size scratch size minus equals page size times 2. Assert that that is less than is greater than 0. And then at each step, what I'll do is I do buffer stringify my got the star and the ampersand backwards there. Stringify my buffer. I need to pull up abstract real quick because I can't remember the interface for this. From I to I plus I to end. Put that all into page 1. Calculate end as I plus the page size. If end is greater than size, end equals size. Then what you do is you stringify one of the other buffers. Buffer like a gap buffer, for instance. And you say, give me everything from I to end into page 2. And then make sure you close your functions with function calls with parentheses. And then after that, you say, assert that, and what I'd love to have, you know, is like an assert that runs, in non-debug mode. So it's like hard assert is still assert X, you know? Else hard assert is, so either way is what I mean to say. We have this hard assert. And then down here at the check, all of these should be hard asserts, because I want to catch these problems even if I don't run in debug and then in release every single time. You know, I don't want to have to go back and forth that much. So, I assert that string compare between these, I'll make my own page compare between page 1, page 2, and page size does not equal 0. And then boom, 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 gap buffer, multi-gap buffer, and rope. Alright, now I just need this page compare function, int page compare, page 1, page 2, page size, and then we'll just run a loop to page size. If page 1i does not equal page 2i, result equals 0, break, int result equals 1, return result. Page compare, Alright. Coder test main. You need the scratch and scratch size. Okay. Now, hopefully, that should catch a bug before... Yes. Oh, wow. That's not what I expected to find. Okay, so what I really need to do there is... size 2... size 2 equals that. Did not expect this eventuality, really, so I'm glad I put those asserts in there, because you never do expect the things that are going to go wrong, do you? It's almost impossible to do so. Okay. And I did that just so that every time these bugs come up, I can tell which one is actually breaking, because I can never tell which assert is causing an assert when they happen. So it's this one that's causing it, and the size 2 is wrong. It thinks it's 9508 08218, and this one says 9508010, 08218, 9508010. So it put in 208 extra characters. Interesting. Where does it get its size? Does it store that? Yeah, it does. Alright, bug catching. Okay, so multi-gap buffer has some kind of issue with its end init, where the size doesn't make any sense at all. Okay, interesting. Size 1 plus size 2. Those do equal the EUL convert out or convert in values. So it's not like it's adding in extra amounts of stuff. So size starts off right here as half of a buffer's width, and then right here we say size 2 equals half of the size. Okay, so each step we're figuring out how much to apportion to size 2 and to size 1. And sometimes, on a rare occasion, that should shrink. If position plus size is greater than total size. Then that means that the size is too big because the position can't be any different. And position starts at 0. I'd be curious to know if there's ever a situation where it comes in here, because it's like it should never go more than one time here where it actually has to shrink the size. That's like the last step. It does that, right? It doesn't do that every time. It should only do that on the last step. So I'll assert when it starts that this equals fixed width buffer half size, and we'll see if we catch anything that way. We don't. So it doesn't have anything to do with that. I still have this suspicion that it's got something to do with the last step of the loop. So multi-gap buffer line 145. There we go. Comes in here, and this is too big, so it shrinks down to 3492. Now, what is start position right now? 9504842. Now, my question is, what was the initial size of this? Right, because we actually have that sitting right here. 9903524, and our current start position, you can see there's tons of room to be made up still. Yeah, there's not even really any way that that's all getting made up right now. What's going on there, huh? Oh, well, that's the init size, but that's not necessarily the output size, right? So start position, okay, and then let me look at position. How much do we have left there? Not that much, right? Because since it's converting in from CRLF to LF, that means that start position can be less than init size, which is why we don't use init size directly. Okay. So we look and see the gap's got the data it needs, and we know how much size we need for each of these, right? Size divided by 2 went into U, and size divided by 2 went into U, with one of you getting the leftover. You got the extra if there was one. You're greater than 0. So you convert this in. 9903, yep. And you become smaller than you were to 1681. $16.95, right. So after that conversion in, you do this move here. Oh. I have an idea of what this could be. I wonder how EUL convert in works these days. Yeah. Okay, so new rule. If /r, then pull it out. If /r, then pull it out. No /r/n checking. Nope. Just pull out all the /r's, because we might not convert the whole chunk at once, right? If I convert a little chunk here and a little chunk here and a little chunk here, if I happen to slice a /r from its end, then it won't. Then if I am requiring them to go together, I would have to be able to like specify to this thing that it's allowed to seek ahead, right? It could be done, but it doesn't even really matter. I don't think it's worth it because I don't want those floating around anyway. So we're just going to say when you convert and you lose all your /r's. You don't keep carriage returns in your files, people. Don't do it. Alright, so we get this far now, and when we come through the start position, looks like that. Yes. Oh, we still broke somewhere during a stream check. 950821950. still off by the same exact amount. So that might mean that I didn't rebuild it and then start over. That's got nothing to do with it, really? That seems somewhat unlikely. I mean, it is unlike. Okay, so it's unlikely that it would have gotten 200. Well, 212. No, 200 and. What is this? A difference of. I gotta check. 208, right, okay. So, out of 10 megabytes, the idea that 208 of the gap boundaries would have happened to slice a slash r from a slash n, right, a character return from a new line, that doesn't seem impossible. So it seems like there should have been that happening. If I come over here and I switch back to the old system, size, and I rebuild with that, it's the exact same amount. So it's like that didn't even happen once. Is the claim there? I don't know. I do not know. Okay, so that's definitely a bug, and I'm taking it out, but that's apparently not causing any problems. I just happened to notice that it was a problem separately from this having a bug in it. So that wasn't the problem at all. Well, I could printf debug this, because I have an idea on what I would do if I was going to do that, so let's try it. Let's pull up, stop it. Let's pull up the multi-gap buffer, and after each step, I will printf the start position. And which step we're on. Okay, and the point of that is, yeah, so there we are at 218. It should go up by roughly 4,000 each time. So I want to see if there's ever a time where it like, the other thing I could do is wait for, okay, so here's an idea. If the sizes are off, forget that. I was thinking I would do like the different from each step and see if any of them look weird, but that doesn't seem like it's going to help, because they're all going to look the same, and it could be happening anywhere in the loop. I don't know that it's actually happening at the end anymore. That seems less likely. So I think what I should do no, not this, is I should pull this test out for now, temporarily only, just because then it'll, well, I don't want it to fail on this one either, and hopefully it'll fail here on the multi-gap buffer compare when it tries to determine equality. It'll show the first time there's an inequality between the two, and then I'll be able to see what went wrong. And if that's going to happen, I'm going to need a breakpoint there to see it, because otherwise it will just assert, and then I'll have, well, no, it'll still work out if I don't put a breakpoint in. Stream check test. Yep, so it's, oh, it failed on the rope before it failed on. Yeah, I should have thought that might happen, so I'll comment that out for now. There we go. Now we're failing where I want to fail. And what I want to do is say, what's the page size right now? It's 1024, so page 1, 1024. What's the eye position? 15360. Okay. Here's watch 2, page 2, 1024. Let's go hunt down an inequality. This could be slow going, but this is what I've got for an idea. 31, 31, 32, 32. You know, I could have it return better idea. Alright, so it's comparing page 1 and page 2, and they look the same as they did before, but now it's going to tell me which eye it was on when it failed. 345. Nice. So that makes our lives easier, because what can be done is I can look and see the nature of the difference. And if that still doesn't cut it, then I can cause the streaming itself to break at that very moment. Interesting, right? Very interesting. And the fact that the buffer and the gap buffer agree and all that, it seems like the one who's wrong is going to be the multi-gap buffer. So where'd the extra new line character come from? And everything else after that just appears to be shifted by one, right? It's like there's just an inserted new line character. I wonder if my fix to whoops, shared. I may have been a little bit sloppy in getting this down correctly. What if the very last thing I see is an R? Then I'll step I forward one more. Got it. That one should still work. Now you're failing when you try to stringify this thing? What's the deal there, huh? 2952, 2952. Out. Loop data, loop size. It looks like it was going along copying all of that out, and then either it read or it either read into or wrote out from a spot that it doesn't actually. It read in from or out to a spot that it doesn't actually have permission to write out to or read in from. Which is odd that that's happening now when it wasn't happening before. Like, I know the sizes are different, but the sizes should be smaller. It's very weird. Let's take a look. I like how when you do that, it's watch 1 that remains visible and watch 2 that it's kind of unusual. Yeah, I wonder if I had modules over here. I don't even know what this is. Like, it's DLLs, I guess, that I'm linked to. Yeah, that's kind of interesting. I should figure out if there's anything useful I can do that with that. Then you drop it there, and it switches to watch 2. Okay, so it's just totally absurd. Gotcha. Two nine 2952. Well, let me just write this up here. This will make my life easier. Right there. If start equals 295 to 192. Okay, so here we are, the third time through stringifying this range, which has a problem, right? Let's figure out why that would happen. In comes start. It's totally a valid range, it decides. Here's the pointer to the gaps. Here's the absolute position of this chunk that we're going to get. Figure out what chunk we need. 750. We're ending on starting and ending on 750. It decides. Okay. Okay, so these three things are always supposed to add up to that, which they do. And the end was greater than size 1, which meant we added in the gap size. Now when we do this here, I'm doing a -1, and that might just be totally wrong. It might be has just never been triggered. Right, so so that, oh man. What does buffer find chunk do when I ask for something which is equal to the size of the whole thing? Yeah, this is one of those things where it's fidgety, like basically end -1, 3 was maybe supposed to, like, end would have been 751 otherwise. And how do I know that it didn't round it down here and up there, right? But if its position equals, then you take that M there. You take the previous M. Whoa! So this thing here is rounding down. That's okay. So this is set up now to round M down, and so that means the -1 is just erroneous. So let me go and change that, 229. Moopaloo asks, why do we need yet another editor? And the answer is because all of the editors are exactly the same for the most part. They don't really do anything interesting, and so we basically have like 2 or 3 editor styles that exist, so really there's not that many. There's many instances of the exact same thing, but there's not that many that do interesting things, so that's why. Also, the ones that do exist are just, even if they are all the same, you'd think that they could, maybe one of them at least, do a good job of that same thing they're doing over and over again, but like all of them have problems, so there's 2 good reasons. But I'm less interested in the second reason. I mean, just doing your job well, you could do that on just about any product. One, two. Alright. So the start and end come in. Now what happens? We don't subtract 1 from end. It gives us 751. And we don't round that down. It ends up being a 1. Right, okay. Cool. And then when we break, what is it? We break because we're remeasuring widths on the rope buffer, which was the original reason we set up this whole testing thing. So, now that the multi-gap buffer is not giving us trouble, we can go back to the initial point of having this test set up, which is to find problems in the rope buffer that would be causing discrepancies in the measured starts from the widths. Bing. Alright, so right off the bat, the size is wrong, which makes reasonable sense. 99035. Oh, wow. it looks like it didn't convert in to end of line correctly. Oh shoot. Yes, that's a problem. I converted it to leave nodes, but I have to... Wow, that's gonna really suck for the rope is gonna have a hard time initializing quickly. Right now, I am wrapping up some experiments to get some concrete data on what underlying buffer type I need to use. I've already figured out some constraints that I need in order to do the higher level some code semantic editing that I want. So I know that I need certain constraints to be met. And so now I'm just looking through, I have 4 different buffer types that have been used in different editors, or that are just, and one that I don't know if the golden array has been used in editors or not, but it could have been, and so it's in the mix just sort of as a baseline if nothing else. And so I'm trying to pick which one to absolutely finalize as the one that everything else will be based on. Once that's done, I will work on some portability interests that I have on how to make the editor something that you can easily run anywhere with sort of, which obviously other things can do that, but it's more than just being able to run it on different places. It's like, first of all, being able to turn it into a plugin. Like, one thing I'd love to figure out how to do, I don't know if this is possible, but if Visual Studio is well architected, which seems unlikely, but if it is, it'd be nice to be able to replace their editor with 4coder, so you could put in an editor here that doesn't suck super hard. That would be really nice. And so if I can figure out how to do that, I would make 4coder something that can be pluggable, and then well, yeah, after that, I'm pretty sure that I'll finally get to the high-level features that I actually care about, but I have to get the rest of this framework in place. So I'm kind of getting those last 2 pieces of underlying framework set in stone, so I can build on top of them now. In the future, I mean. Okay, so I can build on top of them in the future. Alright, so the problem is this. I noticed that the rope buffer earlier today needed to convert in, and so now it does, and it recomputes the weight of a node. They recompute the weight of a node that reflects the fact that it doesn't have carriage returns in it. But it does not have that weight then reflected in other nodes above that node. So all the nodes above have the wrong weights now, which is not great. So yeah, so if you know anything about Visual Studio API plugins, you should definitely stay in touch, because I need someone who knows a little bit about that. I've done like research on the API, but I can't figure out, like, I can't really get my head around it. I know how to program to an API and all that. It's just I can't figure out where to get a code sample or something. So if you have code samples and like an example project or something that sort of shows how to get that up and running, that'd be awesome. The 2 things that I'd love to work on are just making 4coder pluggable so that you can plug it into Visual Studio, and also I don't know if it's possible to make a plugin that sits on top of the debug system so that you could like use information in the debug system to communicate to the editor, because I would do so much stuff with that if I could have like 2 plugins or 1 plugin that uses debug info, so that you can, like, even if it was just like extending the existing debug UI to like have commands that reference back to the plugin. I don't know how in depth you know about it, but like there's some great ideas I'd love to work on in that realm if I knew how to get things plugged into Visual Studio. But in general, the idea of like hyper portability, the ability to make it run on any operating system or pluggable, is going to be a big feature coming up in the next month or 2. So if you have any other things where you'd like to see it be a plugin that are also possible, ideas are always welcome. So yes. What am I gonna do? What is a person like me supposed to do about this situation is what I need to figure out. I think that I have to keep the way this works now because descending the weights initially is set up so that it will correctly traverse across the input buffer. But afterwards, once it's got the converted size, it needs to reconsider that and pass the new stuff up the chain, right? So the other option is that when we first get some input data, we'll just in-place convert it right away. That might be better because that, like, what I'm considering now is like a huge mess of code, whereas the other one and the complexities are the same, and it would mean we wouldn't have to do an EUL convert in here. Yeah, so for this one, what we're going to do is going to be a little different than what I do for the other ones, but it's technically allowed in the system to edit that input data however you want, so why not? When I first begin in init, I'll do EUL convert in where is it? Shared EUL in place convert in. Here's the data and the size. Okay, cool. Init provide page, blah 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 blah. Okay, and then down here the EUL convert in can just go back to being a mem copy. That seems like the responsible choice in this scenario. Well, it seems to have passed. What is it running? I didn't even know what it would do if it worked. So what I should do is, I want to stop that because I don't know if it's like looping or what it's doing. So after that, printf successful initialization, new line. Looks like I should probably clean that up because that one is actually not as good as the other one, and it could be. So let's do that real quick. I see this link. Let me take a quick peek at what you've got here. Redirects to visualstudio.com, integrate, explore. Cool, thanks for this link. I did not find this. I was on MSDN looking at stuff, but that stuff was all kind of crappy. This looks like maybe a little better, so I'll definitely have to take a look at this shortly. So my in-place convert in blows super bad now because it's based on me being dumb. So instead of it being based on me being dumb, I'll do basically the exact same thing I did over there. In fact, there's almost no reason I can think of why that wouldn't just work. Yeah. And since the other ones convert in that way so fast, it seems like a good move. Success. It passes all tests now. Alright, let's run it and see it happen. Successful initialization. Yes, yes, yes. So, yeah, it was basically taking forever to do that convert in because it was dumb. But now it's smart and it doesn't do dumb stuff, which is better. Okay, so on the flip side, the initialization time for the route buffer is much worse, because basically the only cost of initializing the golden array is to convert it in, whereas now the route buffer has all of the conversion time, all of the initialization time it was having, plus all of the conversion time. So that, you know, like I said, that sort of destroyed the route buffer's initialization time. But we're back to having everything work, so that's on the plus side. Let me run this in an optimized build. Yeah, so these numbers down here are obviously bogus, which was the initial problem from a long time ago. Let's take a look at that. Come on, there we go. So why are you sucking so hard, was my initial question. And the answer will lie in whatever is happening here at these plus operations, I do believe. No, wait, stop. Stop. Let me build a debug version. Run it. Okay. Yes, insofar as unwinding the problem stack, it's exactly it. So each problem, you try to debug it, so another problem comes up. And then you try to debug that problem, and another problem comes up, so it's like 3 times in a row now I've had to stop on working on one problem to fix another problem. Expected, widths rec expected. And sometimes you like forget what the first problem was because you're a human, not a computer, and so you don't have a good mechanism for stack-based memory in your brain. What? Okay, so basically what's happening is these don't actually contain valid stuff. Yeah, I have a couple of custom data structures. One's called a golden array, but the other one is coming soon. There's another one coming soon that's going to be based on which of these. The golden array is just the one I was using in 4coder before I like did research and learned about other ones. It's mostly just an array. It's sort of like an array plus a little bit of metadata, and the others all basically use the same metadata plus they have like smarter things. So in a way you could just think of it as an array of characters that doesn't have a gap anywhere or chunks or anything smart like that, right? It's pretty much just the dumbest possible data structure for a text editor that you can think of, without like without actively bringing stupidity to the table. It's the dumbest thing you could think to do. Obviously, you could make a linked list of characters. That would bring a lot more stupidity to the table intentionally. Anyway, so the plan is that I need to figure out why measures functions aren't actually filling out their data, and they're all passing stats out to the print statistics function. So it's the print statistics function which is at fault here. Yes. So I wrote this code that says if stats out, then star stats out, which doesn't do jack squat. So what it needs to do, print statistics, is that needs to be stats. There we go. So not the operator overloading, not the references, just me being a dingbat. That's all that was about. Alright, so we're completing correctly. Now I can build my optimized version. There we go. So interestingly, there's our data on how long it takes each of these data structures to open up a file. You can see the golden array is pretty well suited for opening files quickly, where the others are all competing for sucking a little bit. But there's a lot of variability in there because we're only running each test once. So to really get the right numbers, we're going to have to run the long test now. And by the long test, I mean not the properly long test, but the somewhat long test, where I do each one of these for 100 steps. Okay. Build the optimized version and run it. And now we can sit and chill on it. While we're waiting for that, I'll take another look at this extend the Visual Studio IDE stuff. Such as add new UI, such as menu items and tool windows to add your own tools. Extend the editor and our compilers to analyze and understand your code. Extend Visual Studio Online, Team Foundation Server, blah blah blah. Integrate a new compiler and project type into Visual Studio. Distribute your tool with the Visual Studio shell, even if your users don't have Visual Studio. Looks like the test is done. Let me finish reading this. Reach millions of Visual Studio developers by publishing extensions on the gallery for free. So the thing I'm most interested in is extend the editor and our compilers and add new UIs such as menu items and tool windows to add your own tools. So I'm hoping a tool window is like, this is a tool window. Get out of here. This is a tool window. This is a tool window. This is a tool window. And maybe what I can do is make a new kind of tool window that'll be like under tools, and you just be like, get one of these. But I would hope that it would be a thing where I could have tabs on that window that would work per file, but that's probably possible. Or it wouldn't actually need tabs because 4coder doesn't rely on tabs. I would just have a 4coder window and you'd switch to files the way 4coder does. Each one is loading the same file. It's a 10 megabyte file, to stress it a little bit. And they're all loading the same file, but each one is a different structure holding the file in a different way, right? So it's about how long does it take each one to convert into each of these data structures from just a flat array. And the thing that takes the most time is because it's 10 megabytes of lines that are CRLF, it takes it a little time to convert to line feed only. And that's kind of a problem because, you know, that means that you have to wait 21 milliseconds. Even on the fastest data structure for loading a file, you have to wait 21 milliseconds just to open it, just to get those conversions done, right? And then everybody else does a little bit more work to do other things. And if you look, what I have here is the average time. I run 100 samples. I have the average times up top, the max time out of all 100 samples, and the min time. And those all serve different purposes. So the min time is nice because it gives you the best comparison over which one is really, like, you can see here that the multi-gap buffer actually converts in more quickly than the gap buffer, but within 600, you know, points isn't really that significant. But obviously, no matter what you do, you know, even in the best case scenario, this takes like 13 milliseconds, which is going to take like too much time. Like, it's going to cause a stall that's perceivable. So you got to throw large files at a certain size onto a separate background thread to get loaded in smoothly. And then that's just converting them in. Then they also have to do all the metadata stuff. And interestingly, it looks like maybe the golden array wasn't even the best at measuring starts, which seems surprising to me, but it's not impossible. Measuring widths, it did win out, and at the very bottom we can see that it just barely comes out ahead of all of the others for converting in. So we would only be losing 4 microseconds or 4 milliseconds of time to switch to a gap buffer or to a multi-gap buffer on in conversion. So that's kind of good to know. The ropes, on the other hand, would take significantly longer to initialize the file. I'm going to run that again because I have to read more of this Visual Studio stuff, and because I need to, since I'm only running it 100 times, I want to see how variable that is. I'm a little surprised that the gap buffer, or that the gap buffer is beating golden array on the measuring the starts. But I feel like it might have been doing that before anyway. Alright, what else is happening here? So it's got a create your first Hello World menu for Visual Studio. Let's take a look at this real quick. And I know I'm not showing this on here, I'm just reading it to you guys, because this is what I'm showing off here. Yeah, again, the gap buffer and the multi-gap buffer sort of are right at the same level, and the golden array outperforms by about 5 milliseconds, a little closer to 4 milliseconds. And yeah, the golden array is actually not doing so hot on measuring the starts. It's interesting. So anyway, that gets us some nice hard data on what time it takes to load a file in for each type of buffer. So then let me take a look at how long I've been streaming for. So I think I need to wrap up today's stream, but that's the start of this experiments. I still have to experiment. I still have to run tests on, you know, how quickly they can handle editing the file, how quickly they can do batch edits and seeking through the file, how quickly they can get from one word to the next, how quickly they can, you know, find a specific cursor position, and stuff like that, you know. So I've still got plenty of testing to do. This has just been how to load the file in, and of course these are all slightly unoptimized, as in I still have the ability to go in the future and improve how these things work to make them faster than they are now. It's like the convert in function could still be faster. So this is just an initial pass, and in the coming week I'll put in some I'll throw in more variables that we're measuring, and I'll start trying to optimize and see which one I can make the best buffer choice for me to build my final buffer out of. Moopaloo, what do you mean you could use multiple structs? What do you mean by that? Because I mean the multi-gap buffer is kind of what that is. Unless you have something specific in mind other than what I'm thinking of. I'll go into more detail for you, Moopaloo, on how the multi-gap buffer works, but that's kind of the idea behind that one, which is that you have a bunch of small gap buffers, and when you do edits, you only edit a small one. We'll see when we do edits. I suspect the multi-gap buffer to be the most efficient on single edits. Right, when it's handling like a bunch of just character inserts and stuff, the multi-gap buffer will probably be really fast, because it's basically what you're describing, a bunch of small chunks of data that don't require you to update the whole thing, a whole bunch of data all the time, whereas the other ones will more often require that. But I have an interesting idea of something we need to do first to get actual proper data. you can't just read it like you can't just read the file into a fast one and then convert to another one for edits. I mean that conversion into one for edits takes time. But the idea is that I'm going to do now is take these four sort of basic ideas and work on them, and then I'm going to try to construct an optimal one that's going to be able to handle multi-threaded edits and stuff like that. And it will do some stuff kind of like what you're considering, where you convert out. It's called a scoping buffer, where you have a buffer and then you convert a section of it out into a smaller buffer, do your edits there, and then convert that back into the main buffer. Knuckles has an insane idea, he says. It's an experiment, even saying it out loud. Segregating interface of the program into 3 levels: beginner, advanced, and absolute. Yeah, so actually, I have a plan for something that's going to happen in 4coder eventually, which is, I mean, this ties into some of the portability stuff. And it would sort of be like when you first start 4coder, it'll give you like a tutorial, but not like a sucky tutorial or an annoying walkthrough. Like a lot of editors either come with like just a text file that explains some stuff that doesn't really help at all, or some like perpetual tips that pop up and ruin the whole thing. So I want to find a balance between that somewhere like in the game design realm of like a nice tutorial level kind of thing, where you're like gently guiding towards understanding basic concepts rather than forcing you to do certain things or giving you very little guidance at all. And that will guide you through having the beginner level. And then you don't want to have that every time you run it, which is why you want to have like the config thing, like the idea that you don't download new versions, you just package your own installer from 4coder so that you can reinstall in other places, and it'll keep track of, oh, you're in the intermediate level now, so you don't do that anymore, right? Yeah, so then eventually what you'd be like, someone would say, and another program that does that is GameMaker, actually. I use GameMaker, and there's like a beginner mode, and then a pro, standard mode is what they're called, beginner, and standard. And the thing is that in beginner mode, they hid some things you didn't want, like scripts. Like it was in beginner mode, you could use scripts, but it was like you couldn't use scripts directly. You could only use them within the object system, and they hid some other things that were kind of complex, like timelines and paths and things that were sort of complex data structures that were available for you, but you didn't necessarily need them. And it made the program look more complicated when they were in. So you could be, when you first got it, it was in beginner mode, and then you could like eventually you'd like learn that, oh, if you put it in standard mode, there's some more features you get, but it looks more complicated. So you have to get used to the basic features first, and then you can increase the level of the program when you're ready. For Clippy, yes, like Clippy but not Clippy. For Clippy, it wouldn't be anything like Clippy at all. I don't have any art skills, so like at best it would be like Scribbly. It'd be like Scribbly line would be what you would get if I made you a mascot of tutorialization. So it's kind of an issue. I guess I could get Matthew Vandevant or some other artistically inclined fellow to do me a paperclip mascot if you absolutely are in love with the concept. Anyway, thank you to everyone who came out. There'll be plenty more progress in days to come. I'll probably go back to my usual streaming schedule though, where I stream at about 5 o'clock on Wednesdays. Yeah, thank you everyone. It's been a great week, and I'll see you guys around.